This is the next video on 5-7. Use a calculator to approximate the degree measure to 1 decimal place or radian measure to 4 decimal places of the angle theta with the given conditions. Alright, so they want to approximate the angle where the sine of theta is equal to -4/5 and theta is between 180 to 270 degrees. So let's draw a picture of this real quick, where theta is going to be, where it's going to lie. Well, here's 180 degrees, right? Here's 270 degrees. So theta is going to be somewhere, or the terminal side of theta is going to be somewhere in quadrant number 3. All right, I don't care about drawing up the scale here. I just need to find theta, basically. All right, now, this says sine of theta is equal to -4/5. So let me see. Let me try to find this reference angle right here, theta prime. Well, the sine of one angle gives me -4/5. It's not one of the ones I had to memorize on the unit circle, is it? All right, but notice what we just said. The sine of what angle is -4/5. So the angle that when we take the sine, we get -4/5. Or the angle whose sine is -4/5. The angle whose sine is -4/5. So theta is the angle whose sine is -4/5. How do we write that? Write that as the inverse side of -4/5, okay? Now think about what this is going to give me. It's going to give me, yeah, the angle whose side is -4/5. But whenever I do that calculation, I get the angle whose side is -4/5, but that angle falls between -pi/2 and pi/2, right? So I'm going to get an angle like this, and it's going to be somewhere over there. So what I'm really finding is some acute angle. I'm really finding this theta prime when I do that, okay? So I'm really going to find this theta prime, and then I have to find theta based off of that. All right, so if you take your calculator, because it tells me, okay, if I have a degree measure, do it to 1 decimal place. So if I take my calculator, do it in degree mode, the inverse side of -4/5, I get something like 51.1301 degrees. And I'm going to go out at least 4 decimal places or so, because whenever I do calculations, it makes it a little more accurate. So that's this angle right here, right? Okay. Now, let's see. What do I need to find though? I need to find theta itself. So what do? I'm going to say theta is what? 180 degrees plus this much more. So theta itself, not theta prime this time, is going to be 180 degrees plus 51.1301 degrees. And what do I get whenever I calculate this? I get 233.1. Now go ahead and round it to the nearest tenth or 1 decimal place like they're saying. That is the angle, 233.1 degrees, that falls between 180 and 270, whose sine is -4/5. Notice we had to use a reference angle, and we had to use the inverse sine. Let's do part B. Part B. All right, for part B, they want, or what they give us is, they give us the cosine of theta is equal to 1/17, and theta is between 3pi/2 and 2pi. So what are we looking for? We're looking for this angle theta that falls in this area right here. So let's draw this angle theta that falls in that area. Well, here is 2pi, right? Here is 3pi/2. So my angle theta is going to have a terminal side in this quadrant right here, quadrant number 4. So we could call that theta. What else do I know about theta? I know if I take the cosine of it, I get 1/17, right? So the cosine of theta is 1/17. Or couldn't I say that theta is the angle whose cosine is 1/17. So theta is the angle whose cosine is 1/17. Now think about, all I'm doing is I'm using this inverse cosine to help me find something, okay? I did not start out with an inverse cosine. I'm just using it. So think about this. Whenever I apply that inverse cosine, whenever I put that in my calculator, it's going to give me an angle between 0 and pi radians, right? And it's going to be an angle of this quadrant. So what am I going to have here? I'm going to have an angle in that quadrant right there. So that gives me this angle right here, this acute angle right there. So really what I'm going to end up finding is theta prime. So let's call that theta prime now. So what will theta prime be? I don't know. That's not one of the angles that I'm used to having memorized from the unit circle. So I'm going to use my calculator. It tells me to approximate anyway. Whenever I did this, I got theta prime is approximately 1.5, something like 119. I should have wrote out more decimals. I didn't on my paper, and I don't want to bore y'all by pulling up my calculator and calculating and so forth. So what is that saying? That's saying that this is about 1.5119, right? Now, what does it want me to find? It wants me to actually find what is this angle right here, theta. So how do I find theta, not theta prime? Theta will be what? 2 pi back off theta prime, or 2 pi minus theta prime, which is 1.5119. Get out the way so you can see here. And if we do the subtraction, we get 4.7712. 4.7712. And remember, this is in radians, and it told me to round my radians to 4 decimal places. All right, let's see what else we got here. All right, then your function talks about. Then your book talks about composing trig functions and their inverses. Okay. So it has a little section that says, if I want to take the sine of the inverse sine of x, that's equal to x for if x is between -1 and 1. So in other words, if I compose the sine with the inverse sine, it's equal to x as long as x is between -1 and 1. Also, what if I want to compose the inverse sine with the sine of x? That's equal to x as long as x is between -pi/2 and pi/2. All right. Also, we have the cosine of the inverse cosine, or the arc cosine of x, is equal to x as long as x is between -1 and 1. Then we have the inverse cosine of the cosine of x is equal to x as long as x is between 0 and pi radians, okay? Then we have what? The tangent with the inverse tangent of x. The tangent with the inverse tangent of x. I know you have notes that shows all this, okay? But I'm going to want to point to it and so forth in just a little bit. That's why I'm writing it all down. Okay, so over here, x is an element of the reals, okay? That just means x can be any real number here, okay? Then we get the inverse tangent of the tangent of x. That's equal to x. Now this one's going to be where x falls between -pi/2 and pi/2, but is not equal to either one of them, okay? You can get out the way so y'all can see.